Armature reaction is defined as the effect of armature MMF on the main field flux. Effect of armature MMF on main field flux. Armature MMF solely depends on armature current. When there is no armature current, there is no armature MMF and hence no armature reaction. Since armature MMF is dependent of armature current, obviously it is also influenced by the amount of load current as well as power factor of the load. In the air gap, there are two flux. One is due to main field and another is due to armature current. This flux is due to main field flux and this flux is due to armature MMF. The armature flux reacts with the main field in different ways depending upon the load power factor. The resultant flux is responsible for production of induced or generated EMF. Now let us consider how power factor plays important role in armature reaction. We know that in an armature flux distribution is almost sinusoidal. So let us consider that air gap flux due to main field is given by phi equal to phi m sin omega t. Phi is given by phi equal to phi m sin omega t. Why? Because the the flux distribution over the stator periphery due to main field is almost sinusoidal. So we can represent the main field flux by the equation phi equal to phi m sin omega t. Therefore, induced EMF E is given by E equal to n d phi by dt as per Faraday's law of electromagnetic induction, equal to n d of phi m sin omega t dt equal to n phi m omega cos omega t equal to Em cos omega t. Now we can represent this by phasor diagram, assuming phi m as the reference phasor. Here induced EMF lags the flux by an angle 90 degree. Case 1. When load is resistive, in this case armature current is given by IA equal to E by R equal to EM cos omega t by R, where R equal to load resistance, equal to Im cos omega t. Due to this Ia, there will be a armature flux phi A, which will be also in phase with Ia as shown in phasor diagram. From phasor diagram, it is clear that armature MMF is at a quadrature of main field MMF. So resultant will be like this. It is also clear that resultant is no longer in the same axis as phi, but deviated by an angle theta. So we can say that the effect of armature reaction due to resistive load is cross magnetizing, meaning that it deviates from its original path and makes the flux distribution distorted. How? In the pole tips, the distribution of flux becomes non-uniform. The flux density in the trailing edge is more than that of leading edge. Case 2. With 0 power factor lagging load, In this case, phi equal to phi m sin omega t as earlier, E equal to em cos omega t as earlier, I a equal to e m by x L angle 90 degree cos omega t equal to e m by xl cos omega t plus 90 degree equal to minus im sin omega t. Phasor representation is shown below. This is the phi, this is the E, and this is the IA, and this is phi A. Phi A will be in the same phase as IM. Sorry, IA. Here it is clear that the armature flux or MMF directly oppose the main field flux phi, so the effect is demagnetizing. Voltage regulation will be poor because of armature reaction. Case 3, with 0 PF leading. Here also phi equal to phi m sin omega t, E equal to em cos omega t, Ia equal to em by xc angle minus 90 degree cos omega t equal to Im sin omega t. Phasor representation is as under: phi Ea E I A phi A. The effect is magnetizing. That means it armature flux adds with the main field flux, and voltage regulation is very good or improves voltage regulation. Thank you.
আর দুটো পেয়ে যাচ্ছে।